video on the Sega Genesis Repair Secrets. Now before I get started, I'd like to cover a couple things that may assist you in your repair. Earlier, in addition to this video, Genesis Repair Secrets, Irata Systems has produced a couple of other videos that might assist you, as I say, in your repair. The first video that we did a couple years ago was the NES Repair Secrets, and it was approximately a 2-hour video, and it featured component by component the Nintendo Entertainment System NES 001. We stepped you through each component and how to repair them. As I mentioned earlier, it's approximately a 2-hour video. That video will complement your shop if you are a repair center for video games. The second video that we did was the NES or SNS Repair Secrets video. It's approximately 90 minutes, and it goes component by component through the Super Nintendo system and shows you how to repair each component. With these two videos, in addition to this video, the Sega video, you should be able to repair the three most popular video game systems that come in the front door. Next product I'd like you to be aware of is the Irata Clean Sticks. These clean sticks come in a dozen. We sell them in the pack of a dozen. And what you get is you get some small sticks and some large sticks. The small sticks are designed to be used to repair the video game cartridges. You can use alcohol on them if you'd like, 99% alcohol, and clean them, or you can just use them dry. The large sticks are used to actually clean the console themselves. So between both of these, when you get a dozen, you should be able to clean the full components, full system, full complement of all the components in the system. A couple things that I would like to add here. One is, you'll notice that this is not a very fancy video. We don't have a lot of fancy features to the video. Our intent of this video, as with our other videos, is not to wow you with those fantastic graphics. Our intent is to train you on how to repair the system. And if you'll watch it and review it, and as you get problems that you don't know how to repair, if you go back and review the video, we will do that in this video. The second thing I'd like to mention is that we are a very small company. We would like you to honor our copyright that we have on this video. If you or your friends or an acquaintance or someone else would like a copy of the video, we would ask you to respect our copyright and not copy them for them, but refer them to your distributing dealer where you got your video and have them buy an additional copy. That way, we will continue to be able to produce these as the video game industry changes. We'll be able to have the revenue to make additional tapes and to go back and make these other tapes better for you and to support you. So it's in your best interest to support us, so then we can in turn support you. Now the first component that we'd like to talk about is the AC adapter, and we're going to first cover the 1602 adapter. The 1602, if you'll notice, consists of a long, about a 6 to 10 foot power cord, and then it consists of the main body of the AC adapter with the access screws. If yours doesn't say Sega on it, 1602, then you probably have a generic adapter, and I would skip this part. But if it's 1602, we're going to cover that now. First thing that you want to do before you even attempt to gain access to the internals is do some preliminary checking on the AC adapter to see if you should go ahead and proceed to get inside. The first thing that you'll need is a volt ohm meter. This one has a continuity checker on it, which gives you an audible signal if there is continuity. nice to have when you go to check these out. The next thing that you'll need is the Irata Systems T-handled security opener. And what this does, this serves multi-purposes. It will allow you to gain access to several video game systems that are out there. It will also allow you to gain access to the internals of this should you decide to proceed. This is the Irata Systems security T-handled security opener. Okay, so we're going to set that up there, and if we need it, we'll go ahead and go into the system. The other thing you will need if we decide to proceed is probably a soldering iron and some solder, and we'll get that out in just a few minutes. First thing you need to do is if the AC adapter is suspected, and I'll tell you how to do that. First of all, you get the game console itself. Okay. Plug the AC adapter in the back. Okay. Go ahead and insert the game into the unit, and then you turn it on. And you'll notice right here, the red light should come up. It should turn on. If the red light doesn't come on, there's a couple things that could be bad. This red light obviously could be burned out. It's an LED. That LED could be burned out. Or there could be something inside the machine itself that is burned up, not allowing this red light to come on. Now I have seen people that have tried to go in and fix their own Sega Genesis, and they've pulled the wires off this light. And when we get into the system, this will make a little more sense to you. But if you turn it on and this light comes on, if you plug everything in, the AC adapter, plug it in and plug it in the back, right here on the back, you plug that in, and this light comes on, then the AC adapter's fine. You shouldn't have to proceed any further. Okay? And oh, by the way, you don't need to have a game in it to go ahead and check to see if the light comes on. If the light doesn't come on, then you can suspect there's something wrong either inside of here or the AC adapter is burned up. So what you do is you simply remove the AC adapter, set the Sega Genesis aside, or you can go to continuity on your voltmeter. The first thing you want to do is check the primary windings, and the way you check the primary windings is put your voltmeter directly across the primary windings. And as you can see, our ohm meter reads about 27 ohms across the two leads coming into the AC adapter. If you don't read 27 ohms, or don't read something on here, it can range anywhere from 27 to about 50. If you don't read anything here, then chances are the primary windings of this AC adapter are burned up, and it's not economically feasible for you to proceed at this time. You can go ahead and buy a generic AC adapter and replace this using the specifications that we've just shown you. It should be about DC, somewhere around 5 to 16 volts. It should be able to output about 1.2 to 1.5 amps, is what is necessary to run the Sega Genesis. So it should be a DC, a plus DC AC adapter that will be able to output about 1.2 amps, and it should have the barrel connector on the end, with the outer portion of the barrel connector positive. Okay. So now we've tested this particular AC adapter, and we found that the primary windings are not burned up, so we can go ahead and proceed. The next thing that you'll want to check to look for is burns or breaks or animal bites in the AC cord. So you want to run the cord through your fingers like this, and as you run it through your fingers, you'll usually be able to tell with the tips of your fingers if there's a bite or a burn or a cut or a fray or something in the cord itself. So I'm going to run this one through, and as I run it through, when I get to the end, now that I've gotten to the end, this one is smooth, and so I can tell that this one has not been bitten or burned through or frayed or cut. Often you'll get these in, and they'll be exactly that. They'll be burned or frayed or something, and I'll show you how to repair those in just a moment. The next thing you want to look for is a break approximately in this location. Now, what happens is the customer, when they decide to put their Genesis up, they wrap the cord around it like this, and you'll usually see them wrap the cord like this. Well, what that does, as you can see, is it places a major strain in this area of the AC adapter, so that in this location, the wire is bent tremendously. And over a period of years of wrapping the cord around like that, bending it back and forth, up and back, it puts a lot of fatigue right on this point of the AC adapter. And so the wire will fatigue and break right at this point, right here. So you can cut the wire off about here, pull it up through, and resolder it inside and effect repair. I'll show you how to do that in a moment. The next thing you want to do is, now that the cord, you know that the cord is not bitten through and that the cord is good, you want to go ahead and test the cord to see. And typically, if this is fine, then what it means usually is that there's a break right in here somewhere, and that's what we want to repair. So the next thing you want to do is you take our T-handled security opener and you want to remove these 3 screws. I'm going to go ahead and do that. Set the screws up above. Set them somewhere where you won't lose them, obviously. Now that they've been set to the side, I'll set them up here. The top cover will just lift right off, and now you can see the insides of the 1602 AC adapter. It will then, you'll be able to gently rock this outer cover off and set that to the side. And so now you have the insides of the AC adapter exposed. And as you can see up here, here are the 2 incoming 117 volt AC wires, and these small wires up here will, you can see right in here and right in here, the small wires will burn up, and that's why it's real difficult to reattach those. And so if the primary is burned up, you don't want to proceed. Now down below here, now, as I mentioned earlier, typically what happens is in this portion of the cable, you'll get a break. All right. So what you want to do is you want to note up in here where the cord comes in. You want to note that the lower part is the white, and the upper part is the black. The white being the plus, and the upper part, the black part, being the minus. All right. So what we want to do here is you can then take the AC adapter, take your voltmeter, and take the other end and lay it down close by. I'm going to put this on continuity check so what you can do is you can hear an audible tone when this. Okay, so I'm going to place it here, and you can tell that the outside wire makes contact. Then move it over here, place it on the inside, and then place it here, and you can see that the inside lead makes continuity. Now, if you don't get in any of those, if you touch it from here to the inside or from here to the outside and don't get continuity, then usually, as I mentioned earlier, there's a break in here. So what you want to do, Alright, what you want to do at this point is get a soldering iron, get it turned on and get it starting to heat up, because we're going to do a repair here. The next thing that you'll need, besides soldering iron, is some soldering wick. Okay? And then you'll need a little band of solder. So between the soldering wick and the solder and a soldering iron, we're going to repair this AC adapter. The first thing that you want to do is go ahead, suspect that the break usually occurs within an inch of this strain relief. So you want to come down about 2 inches below it, right about here, and you want to go ahead and clip the wire. Okay? Now that you've clipped the wire, what we want to do is set the wire aside for a second. And we want to remove this old wire. And the way that you remove the old wire, you can do it however you like, but the way that I prefer is to, in this area here, remove the solder using solder wick. And then go ahead, these should just lift right out. So I'm going to set this here. Make sure that my soldering iron is warmed up. See that or not. And then apply the solder wick. Here I've removed most of the solder from there. Remove the solder from there, and then just pull them out. So what you should be left with is 2 clean holes to insert your new wire through. So we want to leave that. Now, a couple things that you'll note here. Again, the strain relief is in this portion right here, and there's some heat shrink up on this portion to keep it from bumping together. Well, what I usually do is you can pull that heat shrink right off of there. Pull this apart, and you can either reuse it or use your own heat shrink. But the white part is the shield. You'll notice right in here, the shield part had this white heat shrink over it, and the black part is the white part is the shield, and that's the positive, and the black part is the negative. Okay, so we're going to set that to the side for now. Now we bring back our cable that we had earlier, and the first thing that you want to do is you want to take this old piece and compare it and notice how long it is, and approximately the same distance you want to strip this wire back. Okay, and be careful that you don't cut through the shield. So now we've stripped the wire back. We have our shield exposed, which I twist. I like to twist. Okay. And then we have our black one here and the shield. So you can now strip a little end off of here. That's 2 strips. Now, at this point, before I proceed, what I like to do, I like to check continuity to make sure that these are going to be alright and that I'm not going to reinstall a bad wire. So insert one of your leads to the center portion. Again, I have my voltmeter on continuity check, so it will make an audible noise if there's continuity. I touch it here, and you can hear that there's continuity there. Then I can ground, I can touch one lead to the outer edge of the shield right here, makes continuity there. So what that's told me is that this cable is good, and I should be able to go ahead and install it back into here, and there should not be a problem. Okay, go ahead and shrink it down. I use the heat of the solder to do the shrinking. Some of you may have a heat gun that you may want to use. Okay, all right. And then you want to tin the tips. And the tips of these two wires. Solder that you can put them back through. Okay. Now usually the little flare that occurs at the end of the wire, I cut that off. Just the tip, and that makes it a smooth wire from there down. Okay. Okay. Now you can go ahead and insert the wires back into the hole. Now we did this because if we hadn't used the solder wick, there would be solder there, and you'd have to desolder the holes before you could put that back through. So now that we have back through, and I bend them up a little to keep them from coming off, then you can reapply the solder to the hole. Okay. Let it dry down. Make sure that the wires aren't poking up too far. And now you've essentially effected repair. Okay. Now, before you proceed any further, again, you want to check continuity to make sure everything's fine. The outer shield should be connected to here. It is. And the inner one should be connected here. And it is. Okay. So now everything we could go ahead and put the cover back on. The strain relief, you'll want the strain relief to slide up to the top. And now you've essentially repaired it. Okay. Flip it back over. And replace the 3 screws. And go ahead and tighten. The next item we would like to cover is the Sega RF switch, model 1603. Now, just briefly how this works, if you took off the cover of this and looked inside, this is what you would see. And the inside of the cover looks like this. Now what happens is, if you look at the back circuit board, this is where your regular antenna comes in. Antenna or your cable television. Normally these transistors here, there's 3 of them. Normally these 3 transistors are turned default to off, and so the signal traces straight through and is output to on the other side to the goes to your television. When you flip on your Sega, it puts a voltage onto about 2 volts, 1 to 2 volts on DC volts into here, which comes into here and flips on these transistors. It shorts them directly to ground, which takes this signal and shorts it directly to ground, and allows this signal to go out to your television now, and your television usually what will happen, I've yet to see one of these RF switches go bad where those internal transistors have failed. Usually what will happen is this F connector, which plugs into the back of your television, this internal tip right here will break. It breaks off, and so this coax with the F connector on the end needs to be replaced. Or more commonly, the coax that goes back to your video game will be chewed or burnt or broken. That's more common. And indeed, I have one in. The way you gain access to this is there are 4 small Phillips screws right here. And just using a regular Phillips screwdriver, you can remove these screws. Okay? Okay, so now you take these 4 screws out, and the cover will just come apart. For the sake of time, I've gone ahead and removed the screws off of one of these, in which the cord has been bitten through. And so you can see here that an animal or something has chewed through this cord. This is how it was brought to me, with the cord chewed through. So I've removed the screws off the cover, and I'll take the circuit board out. And you can see now that there's, again, this is where it goes to your television, and this is where it goes to this goes to your television, this is the incoming antenna. Set those aside, and you can see where this cable plugs in right here. Well, what we want to do is we essentially want to take this and move it up to here, move it up to this portion, and it will then connect the wire and effect repair. Okay? So the first thing that you need to do is check the wire that's been cut off, and it depends on how long the wire is, but this one you can see is maybe about 15, still about 15 feet. I can see right here that there's been a crimp or another small bite, and as I run it through my fingers, I can feel a couple of small bites through the cord. So we're going to have to check this one for continuity before we go ahead and use it to make sure that it's going to be okay. So what I'd like to do is I go ahead and strip the top part off, strip it back a ways, and pull the shield off. And that's the part that we're going to go ahead and use if we determine that it's good. Okay? Give you a little a piece here. So if you zoom in here, you can see that right here there is a small wire, and here's a larger wire, and we're going to use those two to check continuity on the other end of our cable. Get this out of the way here for a minute. Okay, so you have the other end here. Again, I'm going to put my meter on continuity so that you can hear it give an audible beep if you have continuity. Now, unlike the AC adapter, this one's reversed. The shield goes to the outside, so you can hear that we have contact, and this one goes to the point. Okay? So we know that cable is still good, and we can go ahead and use the cable. So while I've got the camera zoomed in here, and while I've got my soldering iron hooked up, go ahead and get this wire out of the way for you. I'm going to go ahead and tin these wires. Again, I get my solder, and I get the wires, and just tin them real lightly, so that when you put them through the holes, they will stick. Okay, I've tinned the very end of those now. Okay. Just like so. Alright. Now what I'm going to do is I'm going to take the circuit board, and I'm going to use my solder wick to remove the solder from this connector right here. you want to do is heat it up, and you'll see if it melts through. This is a pretty hefty one, so um, desolder that one. Desolder the one next to it. And then desolder tip. So there's two connectors there that hold the strain relief, and then there's one where the tip solders in. And so with all of those now desoldered, this cable will just lift off and you can set the circuit board to the side. Now you'll notice that there is again I want to zoom in here a little. You'll notice that right here there's a strain relief connector that's attached to here, and it's also grounded to the shield. And then the tip that's inside insulated comes out and bends down and goes into the circuit board, printed circuit board. What we're going to do is we're going to go ahead and use our wire strippers, and we're going to undo this connector, bend the connector back so that the wire will come right out of it. So we're going to save the strain relief connector right there, and we're going to take the connector that we cut and tin, and we're going to try to approximate the same distance that we had before. So if I hold it up here, I can see where I need to clip that off. I need to clip it off about here. I need to strip it back to about here. Okay, and now I have a wire that's about the same distance as the old one. You can see the old one here. Put those side by side. And now you can cut this part off if you'd like. This bottom part. Cut that off. Throw this part away. Okay. Now what I like to do is go ahead and put the strain relief back on the new connector, like so, and I'll crimp it down with some needle nose pliers. So get your needle nose pliers, and again, I've got a little too much right here that I don't need, so I'm going to clip that off. What's a good idea here is to tin them so that, just tin that one end so that it'll come to your circuit board when you put it through. Okay, put the strain relief back on. Put your shield back down so it'll make contact with the strain relief. Bend that a little so I'm going to turn it back. Back straight. Put that on. Put the outside back. Bend your wires back down so they'll fit back in the hole. And now if you see, we've got our wire sticking out here and the two leads hanging straight down. Okay? Now we get our circuit board back that we've got. Slide the leads back through. Actually, you need to bend this down so it'll go through the circuit board. And then you reattach this. strain relief really is sitting there so that now I know that it's not going to come out. I've soldered the first strain relief now. And I've soldered the second one. Okay. And now I'll solder the wire back together. Tip back on. Okay. Now what you want to do is take your old wire and throw it away. Get back your continuity checker tester. Now, once you've got this properly hooked up, you should be able to touch this to the outside and this to here, and you'll get a proper connection. Okay? Then you'll be able to touch this to the tip, and then you'll notice on the circuit board right here, where we soldered that tip, it comes up and touches to another point. And I'm touching that other point, and I'm not getting anything, so that means I didn't solder. The tip wasn't pushed down through enough. So what I need to do is I need to apply a little more heat and get that solder to flow into there and touch the wire. And now that the tips works, everything should be fine. Now the same thing happens if this one should be the bad one. If this coax going to the F connector is bad, you should do the same thing. Just disconnect this strain relief right here instead of this one. Okay, just remove that one instead of the other one. You desolder down the three connections here, the two for the strain relief and the one for the tip, and replace that. Now what I like to do in that case is many of you have you have F connector to F connector extension cords for VCRs. So what I do is I just get one of those. I measure approximately the same distance. Earth to Andy, what you watch. Okay, I measure approximately the same distance. And then you trim, you can cut this one off, and go ahead and use this to replace that one, okay? And you can get two of these for every 3 or 4 foot patch cord for a VCR. You can get two of these off there and repair two of these, okay? So now that I've showed you how to replace the cord. The same thing occurs if the cord is bad. Again, people will wrap the cord. Let me put it back in here. People will wrap the cord around the connector and they break it. So here we go. One is that these two holes, you want to get the base that has the stand-ups on it. And then there's an arrow here and an arrow here. Okay? These two holes are closer together than these two holes. If they're not, rotate it. Or the hole that the one cable exits should go towards the bottom. So there's a hole here, and a hole at the bottom. And then this circuit board will just lay in like this. Okay? It just fits in right there. And the cord that goes to the Sega comes down and wraps around the strain relief right here. Okay? And then you simply take the cover, the top cover, place it over the top. Alright? And then you replace the 4 screws and tighten them as you expected repair on the RF switch, model 1603. If you'll notice that there's basically 8 functions to this controller. There's the up, down, right, left, A, B, C, and start. So you have 4 functions over here and 4 functions over here. One of the main things that you're going to find on the controller is either cable failure due to an animal chewing through it, as I've mentioned in the part on the RF switch shown earlier, or you'll find that these buttons have just gummed up because they've spilled pop or sticky jelly or something that's got in these holes, and you need to just take them apart and clean them up and put them back together, and everything will be fine. The first thing that you want to do is you want to take the controller and flip it upside down and check to make sure that there's no animal bites in the cable. Again, running it through your fingers, you can tell if there's any bites in the cord or not. You run it through and see, and this one feels pretty good. Okay, and then you want to check just the mechanics of the button. You check the mechanics of the button, pushing on it, you should be able to feel it go down and up, down and up, down and up on all of these. Now there are several companies, and probably the distributor through which you bought this video will also carry the silicon pad replacements that go under these buttons. So you want to check with your local parts distributor to see if they carry the Sega Genesis hand controller replacement silicon pads, and I'll show you what those look like when we get inside this unit. But once you've checked the cable and the cable checks out okay, and you checked all these and it appears to be all right, you may want to proceed to go inside the unit itself and repair it. Now, there's one thing that I'd like to show you here that could show up as a controller failure, but it's not related to the controller. If you look at the front of the Sega Genesis, where the controller actually plugs in, there's a 9-pin connector. It's the DB9 connector right here. It has 9 pins. This is for the controller 1, and this is for controller 2. Okay? And those pins could be bent over. If you can see that all 9 pins here are perfectly straight and aligned, and so everything should be fine on it. Sometimes those are bent together, touching, and when you go to insert this in there, they won't make contact. So you want to make sure that the unit that it comes from, these pins are not bent on the front. If they are bent, you want to take a needle nose pliers and gently bend those back straight again, and work with them until you can get them back straight. But that could also show up as a bad controller. The customer will come in and tell you that their controller's broken when it's really one of these, either is bent or broken off. Okay? So if you've examined that and you have determined that it is indeed the controller is bad, the next thing you want to do is flip it over. Now you'll notice that I'm working on a desk in which I've used a towel. A towel is nice to have because if there's any little particles on the surface of your desk or workbench, you won't scratch it. So get a towel and lay it down. It also helps that if you lose any little parts, they roll out on here. They're easily visible so that you can find them. So what you'll need for this is a small Phillips screwdriver. And go ahead and loosen. There's 6 screws that you'll want to loosen. Okay, go ahead and loosen the screws, all 6. The screws loosened, you can dump out the screws, and then the top will just come right off. You can pull the top off. So set the tops to the side, and now we're exposing the insides of the controller for the first time. You'll notice that there's just a single chip in here that controls that. The chip is a 74 HC 157A, okay, and they're pretty easy to come by. So I'll show you how to replace one of those in a little while. But the first thing you need to do is wiggle. Notice how the cord fits in here as a strain relief. It comes around these two posts and around here, and that way if anyone tugs on this up here, it doesn't pull through down here. Okay? Now there's 9 wires. This requires 9 wires that come through, and you'll notice that they're all attached here and labeled. They're not in order, but they're attached here. 1 through 9 are all attached here. They're kind of in a scrambled order. So remove the cable and lift out the printed circuit board. And what that does is that leaves exposed the silicon membrane buttons inside, along with their associated buttons. This one controls the up, down, the right, and the left. Now the first thing you want to check in here is to see if there's any food particles. In here, or how worn these are. Now if you notice on this one, it's a solid black area. It's very solid, very black, and each one of these is about the same. As this gets old and it wears off, you'll have a patchy area in here, so that the carbon coating that's on the silicon membrane doesn't make contact as it's pushed down. What happens is that as you push on this side, you can see the membrane flex, and that particular button comes up and makes contact with the circuit board. Let me show you the circuit board here. Here's the circuit board, and you can see the button comes up, it pushes up and shorts out this array, this grid. It shorts it together and either grounds it or pulls it high depending on the button. Okay? So that's how this works. And if there's food or anything in between there, it physically can't go down and touch the circuit board. And so you'll want to make sure that these are cleaned out. So I do a visual inspection real at first and see. Now if these look okay, you may want to go ahead and set these aside. But normally what I do is I get a little cap full of water. This is full of water, and you can peel these off and place them down inside the cap. Okay? As you pull them out, just put them in the cap of water to clean them off. And you can put those down in there and just rub them around, clean off. If there's like soda pop been spilled on there or anything like that, you can clean them off. Clean them off one by one, and then I lay them down on the towel, and they'll start drying out immediately. Okay. Now, as I mentioned earlier, the electronic distributor through which you probably received this tape may have replacement buttons for you, and these are very inexpensive. As they wear out, you may be able to look at them and see if they're torn. If they're torn, they need to be replaced, because they don't give you a full spring when you go to push on them. All right. So these buttons you may want to order from your distributor. Okay. So I'll lay those out and let those start drying now that we've cleaned them off. Okay. Then the next thing you want to do is you want to take out the plastic inserts, and if any kind of soda pop or sticky jelly gets in there, it'll adhere to the edges here and here, and then when they go to push on it, it will be too sticky for them to play, and it'll stick. So if they complain that it's too sticky, you may want to submerge this whole thing in a sink of water. Take the whole thing and submerge it in the sink and wash the whole thing out. Wash these holes out, both sides of it. But for now, what I'm going to do is just push these buttons out, and you'll notice that it goes A, B, and C, and they're labeled. If you look on the inside right here, it says A, B, and C. It tells you which button goes where, so you won't be able to get them mixed up. So put them all in there and start letting those wash out. Okay? You can wash those out, and that'll get any soda pop or any kind of gunk that's on them off. You can take a toothbrush and scrub those a little cleaner if you'd like to use a toothbrush. Okay, now we'll lay them all water, again, you may want to use a sink and wash this whole thing out, getting both sides, this side and this side. Okay, set that aside. Now this one is fairly clean, and so I'm just going to lay it aside here as we talk to you about the circuit board. Now you'll notice here that the circuit board is, again, one piece. There's some resistors down here, one capacitor. The connections come in here from the cable, all 9 connections, and then there's the one chip. If you flip it to the other side, you'll notice the chip it's not a surface mount, it's a through-hole solder. So these are very easy to replace. You just desolder these if you suspect it's the chip, and pull the chip out and put a new one in. One hint that you might want to do here, the 9-pin connector is the DB9, all right, and you'll want to test to see if all of these wires are connected. If they come in and tell you that they suspect that this cable is bad, and you've run your fingers along the cable and you can't feel any animal bites, what could have happened is it could have got jerked and some of the wires in here could have broke. So what you'll want to do at that point, let's go ahead and I'll roll these over on the terry cloth, try to get them a little more dry here. Let's set those aside. Okay. This is a standard PCB mount DB9 plastic connector. Okay, it's a right angle connector. You'll notice you'll see that it comes out and goes right angle. Now this is a little different than the one that's inside the Sega, and when we get inside there I'll show you. But this one will work, okay, for the purposes that we intend it for. What I'm going to do is I'm going to just take this end right here, and I'm going to take the 2 connectors. I'm going to take the connector and hook it to here, and that leaves these leads sticking up. And now I can test for continuity between my printed circuit board and my lead. Okay, so I'm going to get you to zoom out here a little, turn on the voltmeter. Okay, I'm going to put it on continuity check. Notice it's on continuity check so that if and when I touch, okay, it makes an audible noise. Okay, so if you come back in here, I'll show you that this DB9 connector right here, it goes like this. It counts as I'm looking at it here, as you're looking at it on the video. This is connector 1 right over here. So this is 1. It's very far one on the left as you're looking at it. The next one to it is 2, 3, 4, 5. All right. So what we're going to do is we're going to check them. We're going to put our lead over here. It says number 1 right on the circuit board. So we place it right on number 1 and we touch here. And we see that there's continuity, so that wire is good. Then we move over to 2 and touch 2. Now we have to jump over here for number 3. Okay, and so forth. Work your way through the connector and through these leads over here and through the connector over here and test one at a time until you've tested all 9. And you'll find that'll tell you if any of the wires inside this cable is broke. If they are broke, then you'll want to unsolder these leads, and you can order these cables usually from the same electronic parts distributor through which you got this video, and you can now replace this cable. All right, but that's a good way of testing the cable. Now the next thing at that point, if you've done that, if you've done all that, if you've cleaned out the top portion of the controller, and you've tried a new cable, you've tested the cable, and everything seems to work fine, what I would recommend is that you replace the silicon pads inside. It's only a couple dollars for those. They need to be replaced periodically anyway, or they'll wear out. And the last thing that you'll want to replace is this chip. If everything checks out and the controller still doesn't work, then what you'll want to do is replace this chip. And again, the part number on that is the C74HC157A. And you can see it's just a 16-pin DIP, dual inline pin. Okay? So So what you do is flip this over, use solder wick or solder sucker, pull all of these 8 off here, pull all 8 here, just put a new chip in. Note the orientation. There's a silk screen white pattern here, and you'll notice that on this end of the chip there's a little, on the silk screen pattern right down in here, there's a notch. That corresponds with pin 1, or the notch in the top of the pin, or the top of the chip. That corresponds right there. So you just put a new one in and solder it back on. And so far, the other thing you might want to do is just kind of clean these off with a cloth, or make sure your hands are clean. Clean them off, make sure there's no food particles in there. That's about all you can do for these. If you've done all that, and it still doesn't work, then it's probably not worth repairing at that point. The only ones that I've seen so far that have come in that are bad have all been associated with cable failure, or food particles in here, or this IC chip that needs to be replaced. It's a good idea to keep 6 or 7 of these, depending on how many of these you're gonna repair. It's a good idea to keep these on hand. Okay. Now let's go ahead and reassemble the thing. Now that we're back. Now that we're ready to put it back together again. So the way I start off is, first of all, start off with C. Now you'll notice that on each of these little plastic buttons, there's a large nub and a small nub. In this particular one here, you can see that there's a small and a large one. Okay. And when you look at the holes here, that corresponds, here's the large one and here's the small one. So they align. When they align, you'll be able to get the proper alignment on this side. A, B, and C. So make sure that the small and the large align. And also they're rotated, so you can't get A, B, and C mixed up. You can if you try hard, but so now we've got A, B, and C back in. Go ahead and put these little silicon membranes back in. Okay. Now, you'll notice on the button here, this button, the start button, is tapered. There's also a slight slant to this button here. Okay? So what you want to do is make sure that it's aligned this way, but also this has a large and a small opening, which corresponds to a large and a small nub. So that goes in like that. Okay? Get all 3 of those aligned. And then the 4th one goes right in there, and you've got all 4 of those on. I don't believe there's an orientation to this. It'll go back in any way. But this does go, it goes on this direction, or you can rotate it 180 degrees if you like, and put it on that direction. So now you see that we have all 4 of these buttons are back in their place, and the up, down, left, right pad is in its place. So now we can hold this and replace our circuit board, and it just snaps right in. Make sure that you have the cable going in the right orientation to make the strain relief fit in properly. Okay, and that the wires are pushed down like they should be, just like that. Okay, and then go ahead and replace the back. The back will go on. And look at the front, make sure everything's okay. Okay, everything seems to be fine. What I usually do is I put on 1, 2, 3. I put on 1, 2, 3 these 3 screws, or I put in 1, 2, 3 screws, and then I test it to make sure everything works fine. And if it works fine, then I go ahead and put the remaining 3 screws in. Now I've added to my components on the table. You'll notice immediately I've added a monitor and a small amplifier. And the reason that I've added these is because they are part of the troubleshooting that you'll want to go through initially when you first get the unit in. Depending on the symptom that they experience when you get it in, will tell you where to start. The first thing you want to do when it comes in, as I mentioned earlier, is you want to take the unit apart, take everything off, and you want to examine it for any kind of obvious breaks or imperfections. Let me grab one here. This one here, for instance, you want to look at it to see if there's the door's missing, if any of the 9-pin connectors are bent. You want to look to see that the on-off switch is functioning properly. The volume switch for the headphones, check that. Just look for anything obvious. Now let me tell you immediately the symptoms that you'll find. If you look right here, there's a 3-4 game switch. Down inside there is a little plastic knob that should stick out. Well, what happens is that's recessed, and so the consumer can't get at it with his fingers, so he has to stick something in there to make it switch back and forth. And it's usually something bigger than the knob, and so by pushing it back and forth, eventually they break it off. And most of the units that you'll get in that complain about a snowy screen, that little knob right there is broken off, and it's either between 3 and 4, or it's hooked on the wrong channel. So you want to look to see if that's broken off. I'll show you how to fix those in the course of the video. The next thing you want to look for is any bent pins along the front, the 9-pin connectors, to see if any of those are bent. If they're bent or broken off, they're bent, you can bend them back. Be real careful to bend them back. If they're broken off, you'll have to replace that 9-pin connector. Okay? The next thing that you'll notice is the on-off switch. I've had several on-off switches that have been broken. So check for the on-off switch. This is a reset button. The reset button should go down and come back up very easily. I've had stuff like soda pop and jelly. They go to push that reset button and they physically touch it, and the jelly rubs off or the soda pop soaks down in there, and that reset button gets sticky, and it'll stick down and reset all the time. So make sure that bounces up and down. If it doesn't, you'll need to take this apart and clean that and make sure that it will do that now that it'll come up and down. So make sure the on-off switch goes on and the reset goes up and down. The next thing you want to check for is, if you look down inside here, you can see the connector in which the game fits. Make sure that all of the contacts are uniform. You can see right about here, there's one of them that's a little off, but all the rest of them appear to be okay. Okay? So you want to look down in there and make sure there's nothing down in there like dog hair. One time I found a chunk of aluminum foil stuffed down in there. Somehow, I don't know how it got down in there, but you can get something like a real fine pick and go down inside there and pick everything out that's down in there. You got to be real careful that you don't bend those. So check those out. Make sure to fit down inside there and clean it. You can take the large one, and you'll notice that you can now open this up, and the clean stick will fit right down inside there. And you can now move it up and down as you move it sideways, and that'll clean the connector. Okay, or you can put it on its edge and move it back and forth. That'll help you clean that connector out. Okay, using the clean stick. All right. So those are the obvious things that you want to look for. The next thing you want to do is get the AC power and plug it in, and then without a cartridge, turn it on and make sure the light comes on. Okay? If everything comes on to that point, you know that the power circuit is working fine, and that because the light comes on. All right? Now, here was what I was talking about earlier. Sometimes the RF modulator, like on this one, breaks, and you can't switch it back and forth between channels on a television. So what they have is, you'll notice that right over here there's it's a 7-pin DIN connector, okay, and there's a cable that goes with it. If you don't have this cable, there's only 5 hooked up here, but if you don't have this cable, why don't you contact Irata Systems in Mesa, Arizona. We have these, or you can get these through your electronic distributor. But what they do is they plug right into that DIN connector, Okay? And then you can plug your game in. Now, I have what's right here, a composite monitor, and you can simulate the same thing if you go through the composite inputs of a VCR. And then I have a small amplifier here. Now the amplifier, unfortunately, this amplifier doesn't have a volume control on it. So when I turn it on to show you how this works, this amplifier will be very loud, and after a while I'm gonna let it run for just a minute so you can see, and then I'll turn it off so that you can hear me talk again. Okay, so what we've got now is we've got our coax coming out of here, and it's got two. One that goes to the sound over here, and one that I've routed to the composite input of this monitor. I'm going to unplug it here and just show you what the connector looks like. This end of it is an RCA connector, just a standard RCA connector. That will go in the back of this monitor, or it will also plug in the side of a VCR. You can plug it in the VCR and go in through the video. The sound amplifier that I have over here required a bit of a modification, so I have a RCA to phono jack here. But normally this cable, all it is a DIN connector to two RCAs, one for audio and one for video, and that'll plug right into your VCR, as I mentioned earlier. Okay, so that's one way of testing. Turn that off and set it to the side. That's one way of testing your Sega if you think the RF modulator is broken. So you can see that what I did there was I turned it on, I hooked it up to the monitor, and everything appeared to be fine. So now I can disconnect this, and I can go ahead and plug in the RF modulator to the RCA jack on the back. Turn on my television. I'll let it warm up for a minute. Let it get warmed up. And now I turn on the Sega. Now you can see from the video that everything works fine. However, the customer cannot switch it back and forth between channel 3 and channel 4 because that knob was broken off on the back. Okay, so what you'll need to do is we'll need to get in there and replace this one, and I'll show you how to do that, as I mentioned later on in the video. Okay. Now, one of the things that the biggest problem that you'll encounter with the Sega Genesis, the biggest problems that you'll encounter are on-off switches bad because it's sticky or they're just worn out, the reset button being bad, the connector back here, again, as I said, it's been broken off. You'll experience bent or broken off 9-pin D connectors, and you'll experience bad gain connectors on the inside. All right, and those are most of what you'll encounter. You'll encounter some broken cases because they've dropped off a counter or been abused or something, but that's the majority of what you'll encounter on the inside. Now, there's a few things that when we get inside, I'll point out some of the chips on the inside and what some of the symptoms are when the chips go bad. So I'm going to go ahead and show you now at this point how to disassemble the unit. So make sure you have a clean area, make sure that it's free of any kind of nuts and bolts or anything that might scratch the front of that. Now there's 6 screws right here that we want to first take out. What I use is a small, well, fairly large, but it's a small cordless screwdriver to make taking it apart a lot easier. now that those 6 screws are loose, you can lay the unit down, and all 6 screws should drop out. And then I usually move them over and put them in a little pile. I put those 6 in a pile up at the top, all by themselves. So I can, I put top to bottom, and then as I reassemble it, I go bottom to top. Now, the top of the Genesis will come off, and the best thing to do is lay it like this and hinge it forward. And the reason for that is this LED on the front, and this is kind of one of the bad designs of the Genesis that I don't like. There's no way of easily disconnecting this connector. It's soldered right to the circuit board here, and then the cables come over here, and what they do is they pass through the wires going to this LED. They pass through this connector, and then they bend them over. So what you have to do is kind of bend the leads back up again, and then work this connector off, and it's kind of tough to do that. Now you'll notice that the longer of the 2 leads, there's one long and one short, the longer of the 2 leads always goes to the red. Okay? There's an anode and a cathode on this LED, and if you get them backwards, it won't work. So the longer of the 2 will go to the red. So you want to disconnect that first, bend that off, and then kind of pull it off and make sure those are straightened. Now right here on the top cover, this is where the reset button is. And the reset button, as you work it back and forth, it should be relatively smooth. If it's not, what you can do is push in on these 2 items, these 2 little catches here, and the reset button now will come right out. You can take a small screwdriver and push it out the other end. And now what I do is I usually wash this off, make sure that it's clean and smooth. I wash it off, wash this hole out, okay, and make sure that there's no sticky soda pop or jelly or anything down inside there. Okay, and once you're sure that that is working fine, you can put that back in, reassemble that. And there's a taper to it. Okay, so put that back in. On-off switch and volume should go smoothly. If they don't, you can rinse this underwater and wash off any residue that might be there. And the door to the opening needs to go smoothly, and you can actually work on that if you want. You might even want to put a little lubricant on there, some plastic lubricant, okay, to make that work a little smoother. Now we can set that aside. Now that we've got it to this point, there's screws all around the outside of this that you have to remove to get this shield off. Okay? And along the front, there's 3 screws, one over here in this corner, one right here, and one right here. Okay? Now those differ from the ones we took off the top, in that the ones that we took the top and bottom off are a little bit longer. So take those screws off, okay? And now to get the shield off, there's a little tab over on this side right here that needs to be bent back. It overlaps the shield right here and keeps the 2 contacted so that any RF interference will be grounded in this particular area. So you want to bend this tab back so that you can get the top off. Okay? Then usually right here on top there's a screw that needs to be removed. Right on top of the RF modulator, remove that screw, and I set it there. And it's a different color. It's a silver screw versus the black screws that we've been taking out. Now there's 3 screws along here, one right here, one right here, and one right here. Okay? Those screws are out, and now there's one last screw right up here in the corner. Okay. So now that all those screws are taken out, the RF shield will just lift right off. And we can set that over with the top. And that exposes the insides now of the Sega Genesis. Okay? And you'll notice a few things. There's a large chip, there's a really large chip right up here. That's a Motorola 68000 microprocessor. Okay? There's a chip right down here, it's a Z80 microprocessor. Alright? Then there's a chip here. That chip right here is a SRAM. It's a RAM chip. there's a RAM chip over here and a RAM chip over here. The rest of these chips, this one, and this one, are generic, or not generic, they're custom Sega chips that Sega has made for this unit. These five chips, the 68,000, these two RAM chips, and this RAM chip, and the Z80 CPU, those chips can all be bought on the open market. These three, you can't. They're tough to come by. But I've seen very few of these actually fail. Okay, I've seen one or two or three of these fail. Rarely do these go bad or these go bad. It's rare. Typically, if you have to go this far, what normally is bad, as I mentioned earlier, are the 9-pin connectors, the game connector here, or if you look up here, the RF modulator, and we're going to have to pull that one out because it's bad, and I'll show you how to fix that one here in just a little while. Okay. Now, if you need to fix the game connector, there's two screws on either side of the game connector that need to be removed in order to further disassemble the unit. And then there's 3 screws over here that need to be removed to pull it off. All right. So what we're going to do is we're going to go ahead and pull those off. Now these are long screws, almost twice as long as the 7 screws we just removed. The 7 black screws we just removed. Okay, so you pull that off on either side of the game connector, and then there's 3 black screws right here that need to be removed. Okay, and those 3 screws are different lengths than the screws that we found over there. Now with those removed, we're almost ready to go. Now right here, this is the sound plug for the headphones, right here. Okay? Your headphones go right in here. Okay? And that lifts up, that comes right off, just a little printed circuit board that comes right off and will flip over, and it exposes the last screw that we need to remove, which is right underneath the slide switch, the volume slide switch for this headphone. So we're going to pull that one screw out, and then all the screws will be out, and we'll be able to remove the printed circuit board. And that screw is the same size as the other 7 that we took out earlier. So now with those screws out, what you want to do is right back here, you want to lift this out. That's the power jack, and it's hooked in by two wires that run from here all the way up. Okay, and that will just lift out. You can lay that to the side. Now you can grab it by this heat sink right here and gently lift it up as you lift the back portion out first, and then it needs to kind of go backwards because of the 9-pin connectors have to fit through these holes right here. Okay, so lift up the back portion, then kind of lift it out and up as you bring it out and up. And what that should do is that should expose the circuit board. We can work on that in a minute. And then we have the bottom, get some of the dust off. We have the bottom RF shield and the bottom of the Sega Genesis remaining. And that shield comes off. You can see that. But typically you won't have to go any further than that. If you're going to do any kind of washing, if there's been a lot of roaches or if there's been soda pop spilled in, you may want to immerse this in water and wash it. Okay. So I'm going to take the top RF shield, the top cover, the bottom, and the bottom cover RF shield, and set those aside. And all we've got left now is the printed circuit board. Okay. Right down here is the reset switch, and again, it's a silicon membrane reset switch, but it's been soldered to the circuit board. So if that's been gummed up at all, you need to be able to push down on it and have it pop back up. So work that with your finger and it should bounce up and down fine. And then this is your on-off switch right here. I've seen several of those broken, and you can get replacement on-off switches. The only thing that's critical is the size of the protrusion, this little lever that sticks up, and its height. So if you can get the same switch that'll fit in there, and there's 4 connectors here that you have to unsolder right here. 1, 2, 3, 4, and that switch will lift right out. Okay? Now, to replace these DB9 connectors, what you need to do is, there's 2 screws on either side that hold the DB9 connector in. Alright? So you need to take those 2 screws out, unsolder these 9 connectors, these 9 leads right here, the 5 on the top and 4 on the bottom, and then you push up on that lever and this will come right out. That DB9 connector will come right out. And you can get these, as I showed you earlier, you can get replacement ones. Now this one is not an exact replacement. It will work, and in place of the screws it just has 2 little nipples that poke down through the hole. And that's fine as long as it'll fit right in there and it will replace that. That's fine as long as you get it to fit properly through the front panel. It won't bend up. They put these 2 screws in here so this won't bend up and break. Okay? Okay. The other thing that you may need to do while you're in here is you may need to check the 2 5-volt regulators. Now, when the Sega Genesis is up and running, it uses approximately, as I mentioned earlier, it uses approximately 1.2 amps to 1.5 amps, depending on if you have one game controller. The game controllers draw quite a lot of current. Okay, so if you have one game controller plugged in up here, or if you have 2, it usually tips the scale between about 1.1 amps and 1.3 amps, somewhere in there. So if you have an underpowered AC adapter that's plugged into here, actually this comes around here and it plugs in here. What happens is it's AC fed into here. I'm sorry, it's DC. It's DC fed into here. It comes up and feeds through this on-off switch, and this on-off switch then feeds it back to dual 1 amp 7805s, which are 1 amp 5-volt regulators. And these both have to be working. If one of them's burned out, it won't run. Okay, so both of them have to be working, and I'll show you how to test those in just a second. They're usually hooked to this large heat sink, and this heat sink does heat up. If you've got both controllers hooked up, and you've got a game in here, one of the larger games that protrudes a couple inches higher and uses extra memory, this heat sink will really heat up. So as you go to work on this, do not remove the heat sink and work on this without the heat sink in place, because it'll overheat the 5-volt regulators and they can burn up. So that's one warning that I'll give you, is to don't test this or operate it without the heat sink in place. Now this particular model, if you'll notice right here, this particular one that I took apart, there's no screw in this hole here or in this hole here. Normally when you take it apart, there's a screw here and a screw here that needs to be removed. For some reason this particular one did not have it in there. And what that does is there's some silicon heat compound between the 7805 and this heat sink. And when you screw that in, it makes good contact and provides a good thermal connectivity route between the 7805 and the heat sink. But this particular one, for some reason, it's gone. Okay? Now, on this one, what we want to do is we want to get down to this RF modulator, because as you can see right here, this little switch right here has been broken off. And so I'm going to show you how to replace that in a minute. But I talked to you about how to test these 7805s. I'm going to show you how to do that here real quickly. As it sits, the unit can operate just like it is. You can go ahead and operate it just like it sits. The RF shield is missing, and so you'll get some interference in the television, but you can still test it to see if it's going to work or not. So go ahead and plug in your RF switch to your television. We'll get the television on and going. I'm going to get the game and plug the game in. And be sure you get this right. The label of the game must face you towards the ports, the game ports. Okay? sure that it's turned off. Take your switch and make sure that it's turned off. Plug your game in. You don't want to be plugging the game in and out with it turned on. And then your transformer plugs right into here. Okay? Now with that all in, you should be able to turn this on. Now you'll notice that the television has more snow in it than it normally does. Okay, that's all right. The reason for that is because we've got the RF shields off, and there's nothing to shield the radio frequency interference, and so it's interfering with the screen. But that's all right. What we want to do is we want to rotate this around now, and you can begin to feel this heating up. You can touch those, and you can feel that those 7805s are getting kind of warm right now. If you get your voltmeter, I'm going to bring it down here, put it down here, turn it on to DC volts. You want to ground, put the black to the heat sink, and then what you can do is you can touch it to one side. The left side should show your voltage coming in, okay, and on both of these. Okay, if you notice the voltage up here coming in, okay, we got 13 volts on one side, and the other side should have 5 volts coming out, 4.9. You see that, 4.9? And this side should have 4.9. Okay, if they don't, if one of these doesn't have the voltage coming out, then it's blown up and you need to replace these 7805s, and I've seen those go bad too. Another way of testing those is to turn them off, unplug all your connections so that you don't have any power to that. Go ahead and flip this to ohms, and then what you want to do is you want to test across the leads and see if the leads any of them are shorted to ground. And sometimes I've seen them shorted to ground, and you'll want to replace them if they're shorted to ground. So all you do, and I'm sure many of you have replaced those many times, unsolder the 3 leads here, or the 3 leads here that correspond to the respective 7805, and then you can simply wiggle it out, pop it out, put some heat sink compound on the next one, slide it in, resolder it, clip the leads, and screw it back in, and you're fine. Okay, so that's how you test for proper power. Now I have seen a couple units that have been struck by lightning, and usually what will happen if that occurs, the lightning will go ahead and follow. I've seen it follow the wires down into the machine, and I've actually seen it jump through the switch, and there's 2 rectifying diodes right here, right down here, and they're equivalent to 2 amp rectifying diodes. Okay, and I've seen both of these go bad. I've seen both of these blown up. So you may want to check these. The way you can check them is with your diode checker on your voltmeter. Diodes, what you do is set your voltmeter on ohms, all right, direction, and you should have a reading, some reading. This one happens to be 1.5 megohms. Test it in the opposite direction. Switch your leads, red to black and black to red. Test it in the opposite direction, and you should have a much, much higher reading. As you can see on this one, it was reading somewhere between 29 and 30 in this direction. Okay. 29 or 30. There you go. So check these 2 diodes. They could be bad also. If you're not getting voltage, if you know you're getting voltage into here, but not getting voltage to your 7805s, it's either the switch or these diodes. Okay? Switch or the diodes. Alright. Now this particular one, we wanted to work on this RF modulator, and I'm going to show you how to replace that switch. So, since this particular one didn't have these 2 screws in it, we don't have to worry about pulling them off. But what you need to do is you need to separate them, pull them away from the heat slightly away from the heat sink. Now, underneath here, there's two more screws. If you'll notice right here, there's two screws that we need to remove in order to take the heat sink off. So, it's your screwdriver. And that will unscrew, and when it's unscrewed, the heat sink will come off, lift right out. And it's a Z-shaped, and you can tell by where the silicon heat transfer compound is dried up a little, where they go. It slides right back on that direction. Okay. Now what that leaves us with is a little RF modulator right here. You can see some of them are longer than others. I've seen some that stretch all the way back and solder in. You can see that there's 3 holes right here, right there. The normal ones that I've seen come all the way back and fill that whole block area up and solder right in there. This particular one happens to be a little shorter, and it solders in to these 3 holes right here on the side. So it solders into these 3 holes right here on the side. Okay, and you'll notice they run up and touch to these also. So we're going to remove this. Now it's a little tricky because there's 3 grounding solder leads right here that ground it to the shield, and then there's these 3 contacts. One is 5 volts, one is audio, and one's video. So that's the 3 signals coming in here. I'm going to go ahead and remove those. Prop this up a little. I'll use this screwdriver to prop it up a little. And we're going to remove the Alright, there's 3 leads here that you need to make sure you have a lot of soldering wattage in order to heat them up enough to desolder them. The shield is soldered to ground, and it's such a heat sink that you have to have. I had to go get a larger soldering iron here, more wattage in order to desolder those. But once they're desoldered, I've taken all the solder off now with the solder wick. I'll set that aside. You usually can put your screwdriver underneath here. Let me once you desolder them, you flip that over, and on this particular one I popped the top off the RF modulator. See that I popped the top off. I'm going to set that there. And then you can put your screwdriver underneath the RF modulator and kind of pry it loose. So now I've just pried this one loose. Okay. Now usually what happens at this point is the RF modulator has to be modified in order to replace the switch that's inside. You can see on this one the switch has been broken off. As I took this apart minutes ago, the switch had merely crumbled, and these are the pieces of the switch that fell out of the RF modulator. Okay. So then what I did was I went down and secured a single pole, single throw switch that allows me to switch back and forth. Okay. Now we're only going to need one of these, one side of this. So what I'm going to do is I'm going to take this and I'm going to clip off one of these leads. Now we're going to pause the video here for a second, and I need to modify this RF modulator. You'll notice that I had to cut a big hole in it where the old switch was. And what I did was I have a nibble tool here, which you can see is notched right here. There's a notch in the nibble tool right there, and what it does is as you squeeze it, it'll take a nibble. It'll just take a little chunk out of the metal. And so what I've done here is I nibbled away a whole area of the RF modulator. And the reason I did that is to accommodate a new switch. I didn't have a switch big enough to go in there. This is one that I just bought at Radio Shack. So what you see is I got this switch, and I nibbled a hole big enough where this will now slide right into the existing RF modulator. And the point would be that I'm going to attach some wires to this other switch and hook it to the circuit board, identical to the old switch, since it only uses 2 of these. And then I'm going to solder this onto the shield, and now I'll have a new switch that will allow this RF modulator to switch between channel 3 and channel 4. And one thing you can do, if you don't want to do that, if you just simply go in here and solder a wire, you can solder a wire between the 2 leads, and that'll put it on channel 3 or channel 4, depending on the RF modulator. And that way they can't switch back and forth, but they can leave it just on one channel if they want. This way, I'm going to go ahead and hook this up, and it will then be able to switch back and forth. So what I'm going to do is I'm going to solder a couple little teeny lead wires on here. I'm going to slide this in like this. That will slide into here, and I'll attach the wires, and then I'll solder this to the shield, and we should be finished, and I can reinsert it back into the Sega. Okay, what you've seen that I've done here is I removed the RF modulator. I then used the nibbler, as I showed you earlier, and we nibbled a larger hole. We modified the hole large enough to put this Radio Shack single pole switch in, single pole double throw, but we turned it into a single pole single throw, so it's off in this direction and on in this direction. Then I ran the 2 wires up here, and you can see where on the circuit board came up to here and hooked to the one IC, this one IC, pin on this one IC, and the other run comes up here. So what I'm going to do is I'll prop this up, and I'll solder these 2 wires on. One will solder on right to that lead of the IC, right there. Right there. You can see that. Like that. And the other one is, I've got a little too much solder on that, so I need to pull some of that off. Tinned it and got a little too much solder on. So now I'm going to solder that one down. To the lead there. Okay, so now what we've got is we've essentially removed the old switch. I made a larger hole, and I brought, now sometimes what you can do is you can solder these directly inside, but this particular RF modulator you can't. So I had to bring the leads out and solder them to where the circuit board went. And again, you can see, as I tilt this, you can see how I've attached the switch and had the 2 wires come out. Then I actually soldered the switch onto the casing to ground it and give it some rigidity, so that when you move it back and forth, it doesn't flip back and forth. It doesn't come loose. Okay? Now to test it, I'll hook everything back up to the RF modulator. Hook the RF modulator back up, as you can see up here. I'll get my AC power, plug it in. I'm going to flip on the television here and make sure the power's off, plug in my adapter, and turn on. Now you're going to get some interference. Now it's on channel 3. I flip it to channel 4, and now as I flip this, it should also go to channel 4. There it goes. Channel 4. I flip it now the other direction. Now it should be channel 3. Okay, and that's the biggest problem. One of the biggest problems you'll encounter with the Sega Genesis is the RF modulator. Now that I've got that, I can flip it off, turn the TV back off, unplug power, make sure that your power's turned off, and I'll put the cap. You can zoom in here, and you'll see me. I'll put the cap back on the RF modulator. This gives you a RF shield again, so that the shield is is so that it's shielded. Now right here you can see that it's butting into this new switch that I put in, so I'm going to have to bend it out just a little to get it to go around the switch. And now it'll close. Now it closes down over it. See? So now we've done repair. Okay, now I flip it over, and I'm going to go ahead and solder back the shield to ground so that we're grounding the shield. Solder those back on. Remember, we had to remove those in order to gain access to the inside. We solder those. Okay, now even though I mentioned it to you earlier to not do anything with the heatsink off, I made that really brief, that moment where we tested it, really brief, because the RF modulator sits underneath the heatsink. So the heatsink sits right here. The RF modulator goes right underneath it, so it's difficult to work on the RF modulator with this heatsink still in place. Okay, so now I'm going to apply some heat compound to the heatsink, reapply it, and put it back together. And then heatsink compound here, we're going to squeeze a little bit out. Okay, and apply it to the back of these 7805s, and also to the bring too close, and also to the top of this. Okay. Now we'll lower that on top, down on top. Okay. All right. So now that we've got the heatsink compound on there, we can, as you remember, this one did not have any screws in here. I'm going to go ahead and I went ahead and found a couple screws that are going to fit back in here. I'm going to put them back in just to make sure that I get a good connection on these 7805s. It's important that you sink the heat away from those, or they'll burn up quicker than you want them to. Okay. Now those have been screwed down very tightly now. Okay. Now the last thing I was going to show you is now that you're in here, now that you got the top off, a good idea is to go ahead and get one of our clean sticks. Okay, the last thing I was going to show you is now that you've got the top off and you're down in here, one of the things you might want to do is go ahead and get one of our clean sticks, get some alcohol and apply it to the surface of the clean stick. Okay, and then you'll want to go ahead and clean the connector. Now one way you can do it is also put it kind of at an angle like this, and you can draw it across the connector. Be careful when you do that. You want a leading edge this way, and then if you go back, a leading edge the other way. that'll take oxidation and any kind of dirt that might be on the contact sheet. That'll take it off. Clean the connector. Okay. So now I'm going to reassemble it. For you and put it back together. Bottom with the RF shield in it. When you reassemble it, you need to be careful that you get the 9-pin connectors in properly here. Again, if you put it in kind of an angle and then put the back down. Now over here, we had one screw, one of the 8 screws. I'm putting right down here in this corner. And then the headphone jack goes over that. It's in place there. Power wire runs along the side here, as you can see. It's close up. And then it kind of flips upside down. It's right down in there, right down in the corner, like that. It's got to go down around that post right here. Okay. Now, the reason that I put the screws back in up here, even though this is a little loose, when we put this back together, we're going to put 3 large screws. 3 of the large screws, if you recall, went in there. And what it's going to do is it's going to hold that down. Even one of those is pretty sturdy now. That'll hold that down against the case. So large screws go here and on the connector. Now I'm going to flip it around. Put the screws down around the connector. Okay, now it's ready. We're ready to put the top cover back on. Be sure to do all this with the power off. You don't want any kind of power problems at all. Make sure that this is down on top. Okay. 3 screws on the front. 1, 2, 3. Rotate it around. This lever right here, this little tab right there folds over. Rotate it back around. There's 3 that go around the back. 1, 2, 3. Okay. And then the final one that holds the shield down is the one right here. Okay. Now we've got to replace the white screw that went on top here that was the heat sink. It holds the heat sink and the shield down together. We put the last screw in. Now what we want to do is, you have the wire that hooks to the LED. We got the 2 LED wires that we had up, and again the red goes to the longest of the 2. So you see here that you've got 2 wires. One is longer than the other. The red goes on the longer one, and it then slides down over the 2, and then you can bend the wires back down again. Okay. Now at this point, what I like to do is over here where the volume control is, I like to move it all the way down, and the off switch, obviously you move it to the right this way. Move the volume switch down and that to the right. Okay, and then when you bring this up to put it on, this volume switches down and the off switch is in the off position. And now it'll just slide right on top of each other. And check this to make sure it's right and the on-off switch is right. Okay? And then you replace the 6 screws and you're done.